Hey guys, what is up? Welcome back to the channel, and today we're going to be doing something a bit different. Today we're going to be using an API called Assimp. This API is a really popular model loading API, and if you're making a game, chances are, especially if it's 3D, you're going to want to load a 3D model. And, to do that, you would have to read through a 3D model file like this. So if we take a look at this, it's quite complicated. We have a lot of stuff here, and yeah, obviously we could make a system where we just read through all this. However, hopefully we can all agree this is really difficult and it's a lot of work. And there's different types of model files too. So this is a collada. This is a collada file, but there's different types of files like OBJ, wavefront. So what if you wanted to load a different file type? Then you would have to make a system that can load that file type. Anyways, long story short, it is a lot of work. Luckily, if you want to load a model, it doesn't have to be that hard. We can use a library called Assimp. So I'm doing this in Java because there's already a lot of tutorials on how to do this in C++. It's just doing this on Java is completely different, and it's a challenge. When I was first doing it, at least, it was really difficult because using this API on Java is completely different. So that's why, and there's not a lot of tutorials on how to do this with Java. So that's why I'm going to go over this using Java. So make sure you are importing the Assimp library. And with that, let's go ahead and get started. Alright, so the very first thing we need to do is actually load this model file, right? So we gotta load this model file. And so let's go ahead and make a method that we can do that. So private static void load model file. Okay, you can name it whatever you want. Alright, and it's going to take a string, just read file path. Alright, next up, we actually have to tell Assimp to load this file, right? So we're going to call Assimp, the name of the class, and from here, we have a bunch of different things we can do, a bunch of different methods, a bunch of everything, right? But the method we're going to want to call is import scene, or I'm sorry, import file, right? Okay, and make sure we go ahead and import this. Alright, and then the AI in front of here, almost all, if not all, methods in this library have an AI in front of the names of the methods and classes. That's just their naming convention. It doesn't mean any functionality or anything. So really, this is the name of the method. They just add this so you know it's from Assimp. Alright. Anyways, I feel like I'm talking too much. Let's go ahead and put in file path. And it actually has another parameter, and the second parameter is called flags. And what this is it takes in one of these values. So it takes in any one of these values. Any value that starts with the AI process, it takes in those. Now, what is this? Obviously, if you're loading a model file has meshes, it has lights, it has scenes. I mean, not scenes, but it has different things in it. And in terms of meshes, in terms of geometry, what this command does, or not command, but like I don't know what to call it exactly, but what it does is it triangulates the mesh. So if it's not triangulated already, it triangulates it. Now there's other ones that you can do without getting too much into it yet. So there's like smooth normal, so it interpolates between the normals, limit bone weight, calc tangent space, a lot of useful things, flip UVs. This is probably something you're probably gonna want to use. But the most important one here the most important one here is Triangulate. Just if you're using anything like OpenGL or DirectX or Vulkan or some graphics API, which you probably are to make your game, that's why you're probably watching this video to load a model. You're probably gonna wanna, use your mesh with like, you're gonna want to triangulate your mesh. So this is what this does. And I promise I will not talk too much throughout the rest of this tutorial. So long story short, this loads the file and it returns something called the AI scene. And the scene is just kind of like a data structure holding all the meshes, lights, everything inside of the file. So from here we have to say, so we're gonna make a pointer buffer and I'll explain why in just a sec. And from here, let's go ahead and import this. I'm gonna get m meshes. So what is going on here? Well, this is the scene, right? We're saying get all the meshes from the scene. Whether you have 1 mesh in this scene, 10 meshes, 50 meshes, get all of them and put them in this buffer. What a buffer is, if you guys don't know, it's just an array, okay? It's just an array. So put them in this array. Okay. So now that we have that, let's make a loop, right? And let's iterate through all these meshes. Let's iterate through all these meshes. So I'm just gonna, to do this, we're just gonna say buffer.limit. And I++. Alright. And yeah, so we're gonna iterate through all these meshes. Yeah. I'm gonna make an AI mesh right here. This is just a mesh object. And to actually create the mesh, we're just gonna call this method. Let me make sure this is imported. Okay. And what this takes is buffer.getI. Okay, what is going on here? Well, like I said, we have a list of meshes in this scene, and it's inside of buffer. It's inside of this array. We iterate through that, and using the index, we get that specific mesh, and we create it. Okay, so it takes a pointer to that mesh. This is a pointer buffer. If you guys don't know what a pointer is, you guys don't need to. Long story short, it takes the mesh for that index and it stores it in here. Okay. All right. So now that we have the mesh, this is great, but we actually need to process this mesh. So we're gonna make a function. Process mesh. If I can spell it right. And it's gonna take in the mesh. Alright. Now, before we continue, we need to talk about something. We need to talk about what is our final result. What do we want at the end? So, whether you're using OpenGL or DirectX or Vulkan, chances are you're gonna want to store all your data inside an array. So let me just explain this in a bit. So how should I explain this? Alright, so OpenGL specifically, this is probably the same for other graphics APIs, but to draw something to the screen, to render something, it wants an array of positions, right? And this array goes like, it's just a bunch of floats, x, y, z, x, y, z, and it goes so on and so forth. And this would be vertex 1, vertex 2, because the mesh is made out of vertices. And each vertex has 3 components, the x, y, and z, right? And these are just, so long story short, this is the array that contains the information for the positions of the vertices, okay? So we need that data to draw this mesh to the screen. OpenGL needs that data. So this is what we want at the very end. We want a float array of positions like this. And I'm going to show you just how we can do that. But this is not the only thing we need. We need a few other stuff. We need also a float array of texture coordinates. And so it'll just be coordinates so we can map a texture. And this is going to be 2D points, right? X, Y, X, Y. Next up, we have normals. And a normal is just a vector that's perpendicular to the face of the triangle. So graphics in general, like everything's being rendered with triangles, but oftentimes when we're making lighting calculations, we want to say, oh, how much light is touching the surface, like impacting the surface. So we use the normal, the perpendicular vector to the face, to calculate that. So this is just a 3D vector. It takes x, y, z. And then sometimes this is optional, you don't need this, but Assimp provides this data so we can get it, and I'll show you how to get it at the end. But it's a color, vertex color, so every vertex can have color data. That would be R, G, B, A. Alright. Okay. So before we can continue, let's make some array lists, empty array lists holding this data, like for this data. I'll be back when I do that. Alright guys, so I went ahead and I just made a bunch of empty array lists holding the data. I'm not holding any data because it's empty, but it's going to be holding this data that I've been talking about, okay? And they're array lists because we don't know how much vertices each mesh have. It's just more convenient to have them into array lists, and we'll convert them to arrays afterwards. Okay, so we have the mesh, so let's extract the positions of the vertices. So to do this, we just say m vertices, right? And this returns a buffer. Now, this buffer is actually AI vector 3D dot buffer. Okay, and I'll explain what's going on in a sec. I'm just gonna call this what's a good name for this? Vectors? Yeah, we'll do vectors. And make sure you import this. Alright. So, alright. This is a vector. It holds 3 numbers, x, y, z. Those 3 numbers are going to be the position. And this buffer is just an array of these vectors, okay? So this is the same thing as this, right? What happened? Wow. It's just the array, okay? It's array. So yeah, this gives us back an array of 3D vectors. So let's go ahead and iterate through that. Alright, and we want to say AI vector 3D vector equals vectors dot get. This will just, so hopefully this is self-explanatory code. We're just iterating through this buffer, this array, and we're getting each index and we're storing it in vector. Okay, so vector itself is a class and we can access some of its stuff. So we can call this and it returns the x component of the vector. So let's go ahead and say positions. That's the positions array list up there. And we're going to say add. I'm gonna say vector. I'm gonna say vector dot x. And then we're gonna go here and copy and paste that, do that 3 times each for each component. Make sure it's in the correct order. And the reason for this is, again, because OpenGL or whatever your graphics API is, it just wants a plain list of floats. X, Y, Z, that's one vertex. X, Y, Z, that's the second vertex. This style. So that's exactly what we're doing. We're doing the X, Y, Z of the first vector, next vector, X, Y, Z. And when I say vector, that's a synonym for vertex in this context. Okay, so next up, we want to access the texture coordinates. So that's going to be kind of similar. So we're going to want to say vector3d dot buffer because we want a list of that. And you know, I can't call it vectors, so I'm just going to call it texture. No, what's a good name? Chords. We'll call it chords for now. Mesh dot that. Okay. Now this is a little bit weird. I don't know why Assimp is like this. It's a bit inconsistent. Over here you can see that we just said m vertices and it gave back a list of these. This one we have to put 0. I'm not too sure what this 0 is. It does say index right here, but if you just keep this as 0, this will return the texture coordinates and it'll list the texture coordinates and it'll store it in here. Okay, and we can just iterate through the list. It's the same exact thing. It's just you have to put a 0 here. Alright, so let's go ahead and iterate. I'm just gonna actually copy this. Okay, so let's go ahead and do this. Okay, so I'm saying give me a list of texture coordinates. We'll iterate for the whole list. We'll store each texture coordinate inside its own vector3d, and we'll store it in an array called text chords, which is this thing right here. Okay, so you guys might be wondering, these are 2D texture coordinates. It's x, y, x, y. There is no z. It's a 2D vector. So after all that, why are we putting it in this vector 3D? If you go ahead and look at this, it returns a 3D vector. I don't know why Assimp did this. It's like that, okay? We have to use this. However, we have to get rid of this because there is no z component. It's only x and y, right? There is no z, so we're just gonna keep it like this. However, yeah, so we're just using a 3D vector but only accessing the first 2 components of it. That's basically what's happening. Alright, so that is that. Next up, let's go ahead and add normals. Now normals is going to be really similar to these two, especially the first one, because it's a 3D vector. So we're just going to copy this. Let's go ahead and take a look at this. It takes a x, y, z. It's x, y, z, x, y, z, just like this one. Okay. All right. So, yeah, we gotta rename this to norm something besides this. So, norms maybe, norms for normals. And we'll just put this here. We'll put this here. We'll do that. Okay. And we'll put this here and here. As you guys can see, this is getting quite repetitive. It's quite similar to this, and it's getting more self-explanatory. And I kind of made a mistake here. This should be normal, sorry. We named it normals. What happened? Here we go. Alright, real quick. So, and we almost made a mistake here. This should be normals. Okay. So we get the normals. And notice how this isn't a 0. And this is what I just find weird. It's inconsistent. We had to put a 0 here. We didn't here. But anyways, this returns the normals. We store in a list of 3D vectors. We iterate. We put each normal inside a vector, right? And we just get the XYZ component in order and put it inside the normals float array right here. Okay, last but not least, and what is this? Let me just quickly fix this. Okay. Alright. Last but certainly not least, colors. Now colors works a bit different. you see how this is 4 components? We can't use a vector 3D because not enough information. We want all 4 we need like a vector 4D. However, there isn't a vector 4D. However, there is a color 4D. So if we say color 4D, this is basically the same thing as the vector, but it holds 4 numbers, and these numbers are the color values. So we want to go dot buffer, and we're just gonna, let's just give it a name. Mesh, no, vertex colors. I just don't want it to be the same name as this up here. We'll set this equal to mesh.m colors. And again, so yeah, this just wants a 0. Alright, so yeah, from here, like we've done 3 other times, we're just gonna iterate. Let's copy this at this point. We'll put vertex color.limit. Okay, we'll copy this. That's a, let's see. Yeah, okay. We'll do vertex color. Okay. So yeah, it's the same thing here. We're just, you know, getting a list of 40 vectors, 40 colors, iterating through it, getting each specific 40 vector, putting it in here, and then from here we can just say colors dot add colors.add vertex color dot r, and this is going to work with RGBA. So I'm just going to copy this a bunch of times, and I'm just going to go RGB and A, and there we go. So yeah, we're basically done here. We've loaded a mesh, right? We've loaded, not a mesh specifically, we loaded a model, okay, and then we iterated through all the meshes in this model, and for each mesh we got a list of vertices, specifically the positions of vertices, like vertex positions, and we stored them in our positions arrays, so on and so forth, for texture coordinates, normals, and colors. So same thing applies for all 4 of these. However, one important thing I forgot is to actually call process mesh. So we want to put in mesh. So make sure you're calling this. Alright, and so from here you're pretty much done. You can go ahead and take these array lists and convert them into arrays. Then you can send them to OpenGL and do whatever you want from there. Draw them, you know. Yeah, you can take it from there. So yeah, so let's go ahead and see what this code does in action. Hey guys, I'm back. So I've pasted this code in an actual working project where we can get something to render. However, the pipeline I have over here does not cooperate with, you know, the pattern or design that we went with. So I'm gonna have to make a few adjustments, but I'll be right back. Alright guys, I am back, and I have adjusted some of the code to match this rendering pipeline that I have made a while ago. So if we go ahead and run this, you guys should see what we have over here. So yeah, we've successfully loaded a model, a 3D model, using the code that we just made. Okay, and this is using an OpenGL render. So yeah, these colors are using vertex colors, they're not using textures. We're using the normals to calculate the lighting, as you guys can see. Over here, when I was modeling this house, I didn't paint the back, but I've painted the front. The front looks much more nice. But anyways, yeah, hopefully this demonstrates how powerful and how cool Assimp is and how useful it is. If we didn't use Assimp, we would have literally had to run through huge files with thousands of lines, and it would be a pain. Assimp makes our lives much easier, so that's great. So yeah, that's basically it. yeah, so as you guys can see, I didn't really change much of the code. I just rearranged the parameters, that is, to match my pipeline. Alright guys, but that will be it for this video. Quick note here is that this code always works, but I have had this code not work. One time it kind of imported a model and kind of messed up the model, and I am not sure why. That could be a problem beyond Assimp. Maybe it's just the way Blender exported it, and Blender is the modeling software I use. So I just want to make that as a note. It could be Assimp, it could be the way the code is written. Maybe we have to make some adjustment. So just keep that in mind. Overall, I think Assimp is a great API, and you guys should always be using this rather than manually reading through model files. But anyways, yeah, so this is pretty much it for this tutorial. I am also planning on making a similar tutorial with Assimp, loading bones and weights, which is used for 3D animations. So we'll touch on that maybe in a future video. Consider subscribing if you're new, because I'm going to be making a lot of game development and computer graphics tutorials in the near future as well. And this is a fairly new channel, so there's still a lot of content to come to this channel. But anyways, that will be it from me today. Thank you guys so much for watching and have a great day.